Lesson 1.4, Task 2. Transform absolute value in quadratic functions. Multiple transformations of an absolute value function or quadratic function occur when at least two of the parameters of the function change. Identifying the effect of changing each individual parameter helps to describe a combination of transformations. All right, so describe how to transform the graph of the parent absolute value function f of x equals absolute value of x to obtain the graph of the function g of x equals -2 times f times 1/4 of x plus 1 all minus 3. Then draw the graph of the function g. All right, so remember, this is your a, this is your b, this is your h, and this is your k. All right, so identify the parameters and their effect on the graph. So match the parameter to each effect on the graph. So a is -2, and that's going to be a vertical stretch and a reflection, because it's negative, across the x. All right, b equals 4. That's going to be a horizontal stretch by a factor of 4. Remember, this is 1 over b, so b is just 4, not 1/4. And then h is -1. H is always opposite the sign inside the parentheses. Anything inside the parentheses is always opposite the sign. So h equals -1 is a horizontal translation left 1 unit. And then k moves you down 3 units, a vertical translation. All right, which transformations occur inside the function f and which occur outside of f? All right, 2 is outside. And you can look right here, if you don't remember, -2 and -3, this is a and k are outside, and then b and h are inside. All right, so the horizontal stretch, that one is inside. Left 1 unit, that's inside. And then a vertical translation down would be outside. And again, that just tells you whether it's horizontal or vertical. Horizontal, remember, you're changing something about the x, and then the vertical, you're changing the y. All right, so the combined transformation of the graph of h to draw the graph of g involves a reflection, both a vertical and a horizontal stretch, and a translation both horizontally and vertically. So because we had an a, a b, an h, and a k, that means we have all of these things going on at the same time. All right, create a mapping rule for the combined transformation. All right, so it says, applying the transformations to any point x and y on the graph of f results in the point 4x minus 1 and -2y minus 3 on the graph of g. So you can use these right here to figure out what the new x is and what the new y is. So this helps you find reference points on the graph. So it says the x coordinates are affected by b and h. Remember, those are inside. And the y coordinates are affected by a and k. Those are on the outside of the parentheses. The parameters b and h change the graph horizontally, and a and k change it vertically. All right, for a point on the graph of f, use the mapping rule to find the transform point on the graph of g. All right, so we're going to use the little rule they gave us above. I think it was 4x minus 1. Okay, so right here, go ahead and write this down. You're going to need this. 4x minus 1, and then -2y minus 3. And what we're going to do is substitute in our x and our y and see what our new coordinates are. All right, so for this point, I'm going to have 4 times -1. 4 times -1 is -4. -4 minus 1 is -5. All right, and then I can check my second coordinate with the second part of this. So negative 2y minus 3. So negative 2 times 1 is negative 2. Negative 2 minus 3 is negative 5. So the second coordinate works as well. All right, check the next point. 4 times 0 is 0 minus 1 is negative 1. All right, check the second coordinate. Negative 2 times 0 is 0 minus 3 is negative 3. All right, check the third point. So 4 times 1 is 4. 4 minus 1 is 3. And then the second point would be negative 2 times 1. So negative 2 minus 3 would be negative 5. And that one works as well. So again, all we did was use the little rule above to find the corresponding points on the new graph. Okay, and you can see here they show like where they plugged it in and how they got those. All right, use the transform reference points to graph the function g. All right, so negative 5, negative 5, negative 1, negative 3, and 3, negative 5. Those are the points that we just found. So when we graph that, this is our transform function. So it took the parent function that was a V-shaped and had a vertex at 0, 0 facing up. And then we had a reflection, we had some stretches, and we had a shift both horizontally and vertically to get to this point right here. Okay? All right, analyze the graph of G. Are the expected transformations exhibited by the graph? Explain your reasoning. I would say yes. We know it was negative, so it's going to be reflected. We know it had a vertical and horizontal shift, and we know it was stretched both with an A and a B factor. Okay? All right, so here's their answer. Yes, the expected transformations are exhibited by the graph. The graph of the parent absolute value function f has its vertex at 0, 0, opens up, and has branches with slopes of negative 1 and 1. The graph of G opens down due to the reflection. Its vertex is negative 1, negative 3 due to the translation. So that's your H and K. And it branches, has a slope of negative 1/2 and 1/2 due to the stretches. All right, that's all for task 2. If you have any questions, please let me know. Lesson 1.4, task 3. Transform absolute value in quadratic functions. Describe how to transform the graph of a parent quadratic function f of x equals x squared to obtain the graph of the function g of x. Then draw the graph of g. All right, so you can see here that there's no a, there's no number in front of f. B is 1/4 because this is 1 over b. And then h is 2 because it's going to be opposite the sign. So it's going to be 2, and then k is 1. All right, so a has no vertical stretch. Since a is 1, it doesn't change anything about the graph. All right, b is 1/4, so that's going to be a compression by a factor of 1/4. Remember, between 0 and 1 is a compression. All right, and then h is going to move you horizontally to the right 2 units, and k is going to move you up 1 unit. All right, which transformations occur inside the function f and which occur outside of f? All right, so there's no vertical stretch, so that's your a, that would be outside. Compression of 1/4, that's your b, that's inside. Horizontal movement, that's h, that is inside. And then your vertical translation up or down, that is outside. And when they're saying inside or outside of f, I think about that as inside or outside of the parentheses because that's what puts that as part of the x value instead of the y value. All right. The combined transformation needed to draw the graph of G involves a horizontal compression and a translation both horizontally and vertically. Create a mapping rule. All right, applying these transformations to any point x and y on the parent graph of f results in the point 1/4 x plus 2 and y plus 1 on the graph of G. All right, so which parameters impact the x-coordinate and which impact the y? Explain your connection to answer of part A. All right, so again, x is going to be from inside, whatever's inside the parentheses. So that's your b and your h. So that's the 1/4 and the 2. And then outside is going to be your a and k. This time there's no a, so that's why it's just y plus k. All right? So here's the mathematical explanation if you want to read through that. And then part C says, for a point on the graph of f, use the mapping rule to find the corresponding point of the graph of G. Okay, so our mapping rule, again, write this down. You're going to need it. 1/4 x plus 2 and y plus 1. All right, so let's start with the first one. 1/4 of x times 1 is negative 1/4. Negative 1/4 plus 2 is negative 1 and, nope, it's plus 2, so it's just 1 3/4. All right, 1 3/4 is the same as 7/4. All right, and then we have y, so we got 1 plus 1. 1 plus 1 is 2. All right, and then we have 0 times 1/4 is 0 plus 2. All right, and then we have 0 plus 1 is 1. And then the next x value, if I plug in 1/4 times 1 is just 1/4. 1/4 plus 2 is 2 1/4. 2 1/4 is the same as 9/4. Just converting from fractions to improper numbers. And those are your new coordinates. So these are the new coordinates for the transformed graph, for the graph of G. Okay, so these are points from f, your original parent function, and we took the rule and applied it to these points, and it gives us our new points for the transformed function of G. All right, use the transformed reference points to graph the function. So here's the 7/4, 2, the 2, 1, and the 9/4, 2. And then you sketch that curve because it's quadratic. It's got to be a U-shaped graph, looks like a parabola. And that 1/4 makes it look very compressed here, okay? All right, are the expected transformations exhibited? Yes. All right, and again, you could read through the explanation. It moves your vertex, and the H and K shift it, and the B compresses it. All right, why are there 3 reference points used in the graph? Well, when you've got a V or a U-shaped graph, you need at least 3 points to get that shape. You know, you could use more than that, but you could not use less than that. If you use less than that, you just have a line. So you need at least 3 points to get a V or a U-shaped graph. All right, that's all for task 3. If you have any questions, please let me know.